Today I'm going to focus on geometry. Okay. So, well, geometry and the probability usually number series. Those are three major subjects. We usually students are weak in these three areas. Okay. So that's why I spend more time than other topics. Okay. Well, let's go back. Let's go over some basic theorems in geometry. In geometry, we know that there's similarity to triangles, right? So we know that if we have two triangles, we want to compare those two triangles. Okay. Now, if they're similar, then how do you check whether they're similar? Okay, first, okay, A prime, B prime, C prime. So I label them in this form. Okay, so they're similar. There's several equivalent conditions. Okay, this angle is alpha. That's this is angle is beta. Here's alpha. Here's gamma. Okay, that'll be alpha prime, beta prime, and gamma prime. And this side is the A prime, and the C prime, and the B prime. Here's the A, and the B, and the C. So this is the theorem in mathematics. So alpha equals alpha prime, beta equals beta prime, gamma equals gamma prime if and only if, okay, if and only if A over A prime should be equal to B over B prime should equal C to C prime. Now in this case, you can use any of this to define the similarity to triangle. In this case, two triangles are similar, okay, considered to be similar. Okay, in either case, okay, two triangles are said to be similar. Okay, they look similar. Okay, okay, so you can, if you verify one of the conditions is true, right? Then the other one is guaranteed. It's proved in mathematics. Okay. How do we check two lines are parallel? Okay, if we check two lines parallel, that's a sufficient necessary condition. So we have an angle here. It's called alpha. And that is angle beta. Okay, so so this is also alpha, right? And this is beta, definitely, because it crossed each other. So two lines are parallel. Okay, if and only if alpha is going to be equal to beta. Okay, so if these two angles are equal, then those two lines parallel. If those two lines parallel, then those two must be equal. So those are the those are the important properties. Now I'm going to work on the following problem. Yeah, take a look at those two lines. Okay, I draw across it. Okay, draw two lines. So this is A, that's a B, and the C and the D. Okay, so we assume that these two lines are parallel. Okay. Now, can you show that these two triangles, this is E, okay, show that this triangle ABE is similar to the triangle that D, C, and the E. Okay, so there's correspondence here. Okay. All right, to prove that, you needed to, I think you just need to verify the angles. They're equal, right? Right. So how do you do that? So let me use a different colors here. If this is the angle alpha, right? Since those two lines are parallel, so this will be alpha, right? And if this angle is beta, then that angle is beta, right? So in other words, then this, because this must be the gamma because they point to each other, right? So you have two triangles that look different, the size different, but the corresponding angles are equal. So A corresponds to D, and the C corresponds to B. So if you if you then you have if you know three of them, you can determine the third one, fourth one, right? So if, for example, AE equals 1, right? EB equals 2, and ED equals 3, right? Questions of what is CE, right? What is C is the length of CE? Then it's not going to be 4. It looks like 1, 2, 3, 4, right? So actually, you have to use the course as use the similarity of the triangle, right? Then you solve the problem. So X corresponds to, right? CE corresponds to B, right? And the ED corresponds to EA, right? So if you use this identity, because these two triangles are similar, then you will see that right, EB or B is the same, right? CE equals 2, and the ED is 3, and the E is 1. So then C going to be 6, right? So ED is a 3, right? Yeah, 3, and yeah, A is 1. Yeah, so it's 6. Okay, that's how to use the similarity. Now, about the angles, we have another important property another important problem. Suppose you have 2 points fixed, A and B. And you have 2 triangles. One is in this position, another one in that position. C and C prime. Okay. They both start from point AB. Very important property is if this angle is alpha, this angle is alpha prime. So here's the important fact. Alpha must be equal to alpha prime. Okay. Now, if P is a center, this is a center. If you connect, okay, those two lines, and you get a beta. And more important, this is going to be half of the beta. Okay. So this is yeah. So alpha equals alpha prime, and it equals half of beta. Okay, so this is a review. And so now we have a problem from MassCont. Okay, this is a problem from MassCont. It's a circle. Okay, and I randomly draw the 2 lines. Okay, so I see this side is going to be 2. This side is going to be 3. This side is going to be 4. So find X. Okay. Well, maybe it's impossible. Maybe you can find it, right? Definitely X is not going to be 5. It's not like a bifurcation triangle. So maybe 2, 3, 4, 5. But that's not true. Okay. For a geometrical problem, right? When you're trying to solve it, if you have no idea, no clue, then this moment you can draw some lines. Okay. You draw some lines. So draw connect lines. I'm going to use a red color. Oops. Okay, so I'm going to call it A, B, C, and D, and E. Okay, so what you get is you get 2 triangles. They're similar. Okay, 2 triangles similar. Why? So first of all, let's color it. Okay, so what kind of triangle we're talking about? I'm talking about this triangle and that triangle. I said that's 2 triangles similar. How do you see that? Okay, so angle at this angle, right? This is alpha. and that'll be also alpha. Why? Because they're coming from B and C. And similarly, if this is a beta and that is also beta, they all come from A and D, right? So that means the triangle AEB is similar, this is called similar, the triangle and D, E, and C, okay? D corresponds to A because of both alpha. So that means the ratio of the corresponding sides, okay, is going to be preserved, right? So 2, over 3. So this 2 is going to be 4 over x. Okay, 4 over x. Okay, right? Yeah, those two sides are correspond to each other. So 4 over x is going to be 2 over 3. Okay, so x equals 4 times 3 over 2. That's going to be 6, right? So 6 is the answer. Okay, so that's how do we get. Right. So my next problem, I want to solve is as follows. Okay, I have a square. This is a square. Okay, A, B, C, and D. Okay, and A, B, C, D. A, B, C, D is a square. Okay, A, B, C, D is a square. And M is a middle point. Middle point. Let me expand. Yeah, choose a middle point. Okay, that's M. So what I'm going to do is so I choose N. Okay, N is going to be 1, 2, 3. So yeah, that means M is middle point. So BM is going to be MC. Okay, but then DN is going to be DN. Yeah, compare with the NC. Yeah, that's just yeah, DN is going to be, let me check. Okay, so DN and C, it's a 2, I divided them into 1, 2, 3, 5 parts. Okay, so it's 1/5, okay, of DC. So let me draw the line right now. Okay, I draw the line, connect it, and draw the line, and draw the line. Okay, so it's a little bit complicated, right? That's the intersection point R here. And this is the intersection point S. So we want to find out, I want to find out the ratio. Okay, and NS to SR to RB. Okay, so I have 3 pieces here, right? Okay. Okay. Now, how do you solve this problem? I think it's that it's a uniquely determined, right? Because M, the middle point is uniquely determined, N is uniquely determined, so the line BN is fixed. But then I know there's the intersection point. Right. But you have to use some kind of similarity. For simplicity, I'm going to call this one X, that one's Y, that one's Z, okay? So first of all, we have we see that the A, B, S, okay? This triangle is similar to the triangle C and S, okay? So those two triangles are similar. Why? Because that's two lines parallel, right? AB and DC. So you have a similarity, okay? So that so what happens? Right. So that then you have to, because similarity, just write down some equations, right? So similarity is the ratio of the corresponding sides A, B, and C should be equal to, right? Right, it should go equal be SB or BS, right? SB and SN, okay, or NS, right? So that's a ratio. So let's see. But on the left hand side, AB over NC, it's clear, right? It's going to be AB is a 5 and the 5 over 4, right? That's how do we divide, right? ADC, right? So that's going to be SR. It's going to be X. SR. No, not SR. So it's B. SB, yeah. SB. So it's going to be Y plus Z, okay? And that will be X, okay? So you get one identity already, okay? But that's not enough for us to get the ratio, okay? Because we don't know where is the point R here, okay? So we have to continue, right? Yeah, we get the ratio between Y and Z, right? So how can I get the ratio between Y and Z? If you know the relation between Y and Z, you can solve the problem. Okay. Right, you need another relationship at least. So here's the idea. I draw this is a middle point, so you can extend it and compare. This is a point C, and this is N. Okay, that's a D, that's a B, that's A. Okay, this is R, right? Right, so that's the intersection. So I think we should use these two triangles to get another relationship. This is a triangle, this triangle, and the other triangle is this one. Okay. And CP is the same as this one. This is because this is a middle point. So if you have 4 pieces here, then have 5 pieces here. 1, 2, 3. Right? 1, 2, 3, 4, 5. Oh, come on, that's too many. Yeah. Yeah. So let me erase one of them. All right. So from here, you can see that these two triangles are similar, right? So use the similarity. Yeah, these two triangles similar. So it's a triangle ABR is similar to the triangle P, P and R, right? Okay. So this side corresponding to this side, okay? So this side is going to be x plus y, and this side is z. Okay, so we have, first of all, we have a AB over NP should be equal to RB over RN. Okay, this is identity, right? So AB over NP is going to be 5 over 9. Why 5 over 9? Because you have a 9 section total on the top, is only have 5 sections. And this is going to be, right, and the z over x plus y. So once you have those two identities, then that's become a algebraic problems, right? So then a pure algebraic problems. So if you have y plus z over x and 5 over 4, another one z over x plus y and 5 over 9, can you find out x to y to z, right? So, and the answer is yes. Right. Okay. So we just needed to, we just needed to solve this equation. So this is the algebraic problems right now. Okay, let's try to figure it out. Assume by the similarity, you have these two equations. Okay, and okay, so I'm going to multiply this out, right? The first equation, y plus z equals 5 over 4x. Another equation here, z equals 5 over 9, x plus y. Okay. So I think you have 3 equations, 3 unknowns. You can express the solution. You can solve for x and y, and in terms of z. Okay. Then you can find the ratio. Okay, how about this? So how do you do that? Now you can find the z also. Solve for z and let's find the z. Okay, express z and y in terms of x. Okay. So z is going to be 509 over x plus x times x plus y. So I plug into the first equation. Okay, then you get the relationship between x and y. Okay, right? How to do that? You multiply both sides by 4 and 9, right? So 36y plus, okay, 20 because 4, right? X plus 1, okay, 55x. Yeah, multiply both sides by 9 times 4. So multiply this out, 36y plus 20x plus 21 equals 45x. And I have a 56y. Then move 20 to the right-hand side. I have a 25x. Okay. So I got the relationship between x and y. Okay, but I can express y in terms of x. Okay, then I put into this formula, right? So x plus y, right? So it's gonna be 5 over 9, and x here's 25, 56x. So you express everything in terms of x. Okay. So now let's simplify a little bit, right? So it's 5 over 9 and 56. 56 plus 25, it's going to be 81, right? Right? And here's x. 81, divided by 9, right? So it's a 9, 56x. Okay, so now it's clear, right? Now it's clear. Okay. You have this, right? So x to y to z is going to be x, right? And the y is 25 and the 50x. And here's 45, 56x. And then you can multiply both sides by 56. Right, so that's the ratio. Okay. All right, so the next, so this is just become a, algebraic problem. So you can actually generalize this result. Find, yeah, you can generalize this result, okay, and make a, use the same idea, but you can get the very general formula. Okay. It's not a big square, it can be rectangle. All right, so we go, let's look at another problem. It's still a circle, right? And here's a point P, and that's the center. Okay. So we know that the distance between between P and the center is 9, and the radius R is going to be 15. Okay. So we want to find out the number of these line segments between A and B. They're passing through the point C, which has integer lenses. Okay. So how many line segments A and B passing through P with integer length? Okay. Wow. Now, to solve this problem, right? It sounds like you have infinite many there, right? But you can move the point. Yeah, you rotate. Yeah, you move the point A, then the B also change the location. But it changes slowly, right? The length of the line segment changes slowly. Continuously, sorry, continuously. Sometimes integer, sometimes not integer. Okay. And can you determine all of those line segments with the integer length? How many of them? Right? When you get a problem like that, what you should do? I think you should look at some extreme cases first. Okay. What is the shortest one? What is the longest one? Okay. Any ideas? Yeah, the shortest one is the one perpendicular to this line segment. So this is AB. Okay. The longest one will be this. It's connected. Okay, this is C, and here's a B, and that's A. That's the longest one. And I think that both are integers, right? AB is going to be double the radius, right? In the integer. And how about in this case? Is AB an integer? I think so. Okay. Because this side is 15, this side is 19. And this side must be 12 because 9 squared plus 12 squared equals 15 squared from the Pythagorean theory. Right? So can you get ideas and can you count how many of them? So in this case, AB equals 24, right? The length is 24. This is the shortest one. The longest one, 30. Okay. So AB, from 24, you can change, right? 24, 25, 26. When the length gradually changes, continuously changes, right? And then it takes integer values sometimes. Okay. So this is the extreme case, this is the extreme case. And there's only one perpendicular to, the shortest is unique, the longest are unique. But for any integer between them, okay, there are two lines here. You know why? Yeah, for example, if this is the one, right, then the another one, same. Okay, so you always get two. Get a pair of the line segments with integer lengths passing through the point P. So total will be, okay, the answer is 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 1. Right, 1, 2, 3, 4, 5. Yeah. So total 12. Okay. All right, now I'm going to ask you work out the next problem. This is not that complicated, but I wish you are able to figure it out. So this is a we assume that this is a swimming pool, right? Okay. So this is a swimming pool. So around what? Okay, here's a story. Okay, what you're gonna do is you're going to hit the sidewalk. Okay, hit the sidewalk, and so the width is gonna be 3 feet. So you're going to put some bricks. Okay, this is sidewalk. So you go to the store and you're trying to buy the bricks, and then there is an instruction there how many bricks you needed to cover how much area. Bricks, yeah. Then you have to, okay, my God, I forgot to measure, the area. Okay, but what you remember, okay, the parameter of the swimming pool is 218 feet. And that's what they remember, because there was a kind of, that's on the record. Question is, do you need to go back to measure the area of the sidewalk, or you could, based on this information, can you determine the area of the sidewalk? Okay, based on this information. So please think about that. Okay, if you say no, you have to give me a counterexample. So you have two examples, right? The same parameter, but the area is different. Yes, sounds like we are not able to determine the area, right? So Michael said he can determine. Okay. Now, if you're not sure whether you can determine or not, just go ahead to compute it, okay? Then you say, I don't know. I don't know some information. I need it. So how can I determine the area? Well, you don't know the dimension of the swimming pool. That's true. So let's call it, one side is X, other side is Y, okay? But at least I know that X plus Y, twice of that, that's parameter, is 218 feet. Okay, so now let's calculate the area of the sidewalk. How can I calculate the area if I don't know I use a subtraction to calculate area. Okay, so this side will be Y plus 6. This side will be X plus 6 because you add the two sides. Okay. So the area of the sidewalk is going to be the area of the difference of those two areas, the areas of those two rectangles. Okay, X times Y is the area of the swimming pool. Then you then you can tell whether it can be determined or not. Before say that, yeah, we have to do some computation. So I multiply this out. It's X times Y and 6X and 6Y and 36 and times X times Y. Okay, and I find out X times Y is gone. All I have here is 6X plus Y and 36. Okay. So I know 2 times X plus Y. Of course, I know 6 times Y. It's a 3 times that, right? 3 times 218. Okay. So let's calculate. So I use my calculator. Okay. 218 times 3 plus 36. 690. Okay. You see, we solve the problem. It's independent of the dimensions. Only depends on the parameter of the swimming pool. You can determine the you can determine the area of the sidewalk. But you can also estimate. The reason is, how do you estimate? Suppose you cut it here, right? And you open it. What you do is you get a string, right? Very long string. But of course you can, there's a problem at the edge, at the corner. So the total length is going to be 200, right? 218. And then the width is going to be 3 feet. But if you multiply them out, actually, you will not, the 208, you see, 218, okay? Let's open it, right? So you cut the 4 corners, okay? If you cut the 4 corners, you can open it and make a rectangle. Okay, after you remove those 4 corners, that's another way to do, right? After remove these 4 corners, think about it, you can cut it, right? After remove these 4 corners, then you can you have 4 rectangles, right? These 4 rectangles and then lined up. Then you get, then you get those 4 rectangles. Total length is 218. The width is 3. So 3 times 218 is again the area of the 4 rectangles. But you already removed the 4 squares. So you add them together, 4 squares. Each side is 3 times 3, right? And then times 4. So that's why you get 690. Okay, that's another way to do it. Yeah, you remove those 4 squares. And that's why you open it and you get 4 pieces, 4 rectangles, and put together, you get a round rectangle. Okay, so this is another way. There's a couple ways to solve this problem. All right, our next problem is we want to I bought a piece of fence. I'm trying to make a vegetable garden. Okay, but I have to divide it into two parts, equal parts. So total length of the fence, okay, is going to be 100. Okay. So I want to decide, here's X, here's a Y, it's a Y. That's X and X. I want to determine X and the Y such that the total area of these 2 regions are maximum, okay? Determine X and Y such that the total area is going to be its maximum value. Okay, so this is a maximum value problem. Okay. Now, if I do not divide it into 2 parts, and I think common sense tells me the square has the largest area if the length is fixed. So it's very simple, just decide. Now you have to use cut one piece of a fence and put it in the middle. So divide it into two regions. Then what is the dimension of this, okay, rectangular garden so that you have maximum area, right? Now you cannot make it a square. I don't think so. Yeah, you cannot say, oh, it must be square. Then I put another piece in the middle. And how many pieces do I have? Okay, 1, 2, 3, 4, 5. So 100 divided by 5, that is going to be 20 pieces each, right? So then the area in this case is going to be 20 times 20, it's 400. So question is 400 the largest area you can get, right? So here's, 20, 20, 20, 20, 20, right? So it's easy to cut and you make a square. The question is 400 the largest area? Is 400 the largest possible area? Okay. Okay, this is kind of research problem, but you can use the mathematics, you can solve this problem. Okay. So it's very, very realistic, right? So you bought a 100 feet long fence, and you want to, at the very beginning, say, let's just make a garden. But for some reason, you have to divide it into two regions, and still use that one piece of fence. Okay, think about that. Okay, I'll give you 1 minute to see if you're able to figure it out. Right, let me start the problem. All right, I can tell you that it's not going to be the maximum area you can get. Okay, this is not going to be the maximum area. Okay, let's go back to the picture, right? So all right, so this is a picture. So here's a y, that's the x and x, right? How many x there? How many y there? So 4x plus 3y is going to be 100, right? The area is going to be, the area is going to be 2x times y. Okay, so we want to find the maximum value for area. So that's two variables here. So what I'm going to do is I'm going to solve, it doesn't matter, solve which variable. I can solve for x in terms of y. So it's 100 minus 3y divided by 4. Okay, I can even solve for y. You know, maybe you prefer y, but x, then you solve for x. Yeah, let's solve for y, right? So 100 minus 4x divided by 3. Okay. So I'm going to put it here. So area is going to be 2x. Y is going to be 100 minus 4x. So it's going to be 2 over 3 x 100 minus 4x. I can even take a 4 out. So if I take a 4 out, it'll be 2 times 4 is 3, 8. It's 25 minus x. Okay. So this is a, so x clearly, x is positive, but x cannot be larger than 25. Otherwise, the area is going to be negative. Now, you don't need to use a quadratic formula ideas here. There's a quick way to do. Okay, first of all, the leading coefficient is negative. So the graph is going to be parabola opens downward. Okay, so this is a little bit beyond what you should learn, right? That's a nice, nice grade math or not. Okay, but if you don't use that, you have to use the quadratic function to study. Okay, so we get the graph. This is a y-axis, this axis. So when x equals 0, a is going to be 0. When x equals 25, a is equals 0. So between 0 and 25, a is positive. That's to have a positive area. So question is for what x you get the maximum area, right? So a has maximum value only when x is the middle point of 25, so 25 over 2. Okay. So in this case, a is going to be 8 over 3, 25 over 2 times 25 minus 25 over 2. So if you multiply this out, now you get 25 over 2, and here 25 over 2. Now I'm going to do the calculation, okay? So 2 canceled out, that's going to be 2 here, okay? Right? So 25 times 25 times 2 divided by 3. So it's about 416.6. Okay, so this is bigger than 400. Okay, that's our solution. Now, how to find the maximum value of, how to find, this one I use a picture here, right? In general, okay, if you are given a function ax squared plus bx plus c, so a is negative, okay, then you can always find a way to express in this form. Okay, I can show you how to do it, okay, step by step. And you can also get to the formula for h and the k. Okay, how to get h and k? Let's multiply. If we multiply it out, you can get h and k. So a x squared minus 2hx plus h squared plus k, right? So you get ax squared minus 2ahx plus ah squared plus k. So you see that compares both sides. So this should be negative 2ah should be equal to b. So h is going to be negative b over 2a. So you get the formula immediately. And how about k? Ah squared plus k equals c. So from here, k is c minus a times h squared. And I already have h. Okay, so it's negative b over 2a squared. And if I multiply them out, and get square and the 4a squared. So AA cancelled out. Okay. And if you want to put them together, it's 4ac minus square and here 4a. Okay. So there's a formula, that's how do you get h and k. Okay. Anyway, so if you have a x minus h squared plus k, and the a is a negative, then this will be less than equal to a negative number, right? Plus k, because this never be positive. Okay, that is true for any value of x. And then and the y it can be k when x equals h, right? When you plug h for x, you get k. So that's why k is the maximum value of y. Okay. If there's no restriction on x, sometimes you're given a restriction on x, that's a different story. Okay. If x can be arbitrary, then k is going to be the maximum value. Okay, let's put them into practice. So area is going to be x 25 minus x. Let's just look at it like that. Multiply by constant, same, right? So this is going to be x squared plus 25x, and their leading coefficient is negative. Okay, leading coefficient is negative. So this should has a maximum value. The question is, what is the maximum value? How do you find it? And that is going to be negative x minus h squared plus k. So if you get, this a is negative 1, right? A is negative 1, so that's why you have a. So clearly, if you can determine the constant h and the k, and then you get the maximum value, right? Because this is always less than or equal to k. Okay, k is the maximum value. Okay. So all I have to do is define h. So you multiply this out. If you forgot the formula, that's fine. Multiply this out. So I'm going to get negative x squared plus 2hx minus h squared and plus k. So I want to compare with, right? Compare with that. So x squared is okay. 2h equal to 25. Negative h squared plus k equals 0, right? So from here, I get h is going to be half of 25. And from here, I get k equals h squared, which is 25 over 2 squared. Okay. So that is my maximum value. Yeah, that is my maximum value. Okay, so we conclude that a equals this a, right? I use a, no, but I forgot the constant. I don't need a constant. So x had 25 minus x has the maximum value k, okay, which is 25 over 2 squared. Okay, it occurs when x equals h. H is going to be 25/2. But that also matches what we see from the picture. Yeah, let's go back to the picture again. If you are able to draw the graph, right? And this is a parabola opens downward. And the graph must be symmetric about the axis. Now, what is the axis? Axis should be in the middle. What is the middle? That's 25/2. Okay, and this is the highest point. Okay, for this function. So what is the y value when x equals 25/2? So the a value is going to be, right? And from here you can also get it. It's 25/2. 25 minus 25/2, that'll be 25/2 squared. Okay. So this is the highest point on the graph. And that is an absolute maximum value. Okay, so this is about quadratic functions theory. Okay, and I hope you you understand this. And we remember, if we give a quadratic function, right, y equals ax squared plus bx plus c equal, right? And if you want to draw the graph, if a is negative, just as c is negative, right? So in general, graph looks like that. Okay, in general graph, and this is called x-intercept, right? And how do you find the x-intercept, right? Okay, so if you already know x1, x2, then this function can be written in this form. So if you solve, so how do you find x1, x2? You just solve the equation. And you can solve this equation using quadratic formula. Okay, so you can always find it. And you get x1, x2 depends on the choice of plus or minus. Now, then you have a question. So what happens? We assume that here's a is negative, okay? We assume that, okay? So what happens if b squared minus 4ac is negative? If b squared minus 4ac is negative, then you have no real solutions, okay? Then ax squared plus bx plus c has no real solutions. So if you look at the graph, that means no x-intercepts. And that's possible. For example, this is no x-intercepts. Its graph is completely below the x-axis. Okay. And formally, you still can say you have two solutions, but the solutions are complex numbers. Right. So that's about the quadratic function. I hope you understand the quadratic function and its graph. If you're not familiar with it, then spend a little bit more time. And another thing I forgot to mention, you should